This video has been supported by Skillshare. Hey guys, here's a bit more CNC trivia that didn't really fit into any of the previous videos. First, Haimer have very generously sent one of their 3D digital tasters. Without it, I would have to locate workpieces caveman style, by driving into them and looking for the first chips to fly. That may be useful sometimes, but it's destructive and it gives me only a binary information, contact or no contact. Haimer, on the other hand, is able to quantify probe deflection in all directions precisely and with a micrometer resolution. Before making use of that unique ability, however, I've got to solve a little large problem. I can't quite seem to fit the shaft into my HSK tool holders. The manufacturer has an easy solution, a smaller analog probe, pre-fitted with its own HSK tool holder. But since getting away from caveman methods was what started this whole endeavor in the first place, I don't think an analog probe is an option for me. So, bigger hammer it is. The beautiful original shaft has a secondary function. In addition to this long axial screw, it has 4 radial grub screws and a precisely ground flange surface. The idea being that squareness is always guaranteed, while the centricity can be adjusted by the user. My initial shaft replacement idea, consisting of one ground fit bolt, doesn't have any of these luxury options. At least the spindle can grab it this way, but without guaranteed centricity or squareness. This arrangement is also pretty long. With it, I couldn't measure anything in the upper third of the machine volume. As luck would have it, my spindle manufacturer Megatron has given me 2 extra HSK tool holders, which were slightly abused in product testing, but are still too good to be scrapped. This one's definitely good enough to become a 3D probe holder. Except it absolutely doesn't want to. It's a really hard material as expected. And even just widening an existing central bore is quite the adventure. If only I had any solid carbide hard milling tools within reach. Those are already busy making my own wonky version of soft jaws, with which I'm going to clamp the tool holder in the vise without leaving dents in any of the 2 participants. Nothing new here at the moment. I'm still super dissatisfied with the sticky aluminium powder. I'd like to try a different non-oily minimum quantity lubricant. If that doesn't help, I'm totally going to try flat cooling. I have space and an almost full enclosure already, so why not? These large chips are nice and completely unproblematic. Something is squeaking though, and I haven't found out yet what it is. Oh, on a completely unrelated note, there's still a 3D printed X-axis bearing block in place. It's becoming a running gag with its miraculous longevity, but I think today it's gotta go. While we are here, check out how comically long and inaccurate the bolt solution would have been. I've already used this setup to indicate vise parallelity in another video. That's only a fraction of what's possible when the spherical probe tip is centered perfectly though. Let's make that happen. I've just angle ground these 2 pieces off of the remaining stock material, for time-saving purposes. And because I really only need 2 known good surfaces. Precise center finding of round pieces will actually be one of the fields that Haimer will excel at once I can use it. This thing will be intentionally oversized and adjustable, so not a whole lot of precision needed. So far I've broken a few of those tiny 2mm PCB end mills. And I've worn out an expensive carbide end mill with over temperature by going too slowly in steel. No real accidents yet, and I'm trying to keep my best trigger finger on the emergency stop. Whenever running something for the first time, to keep such a clean record. Finally, the gamer skills paying off. Alright, I'm not using compressed air or mist cooling for this whole thing, and I'm holding my breath, because it's still quite a tense moment, and I want to keep this hardened, abrasive dust under control. What can't be vacuumed away will totally be mopped up with an oily rag later. I don't want any of it to stay. Looking at the almost accident in the beginning, I think I've overestimated the hardness of this material quite a bit. Therefore, I chose a way too small optimal chip load and am getting thermal problems again. Well, at least this anneals the more or less hard chips. The first operation was just to shorten the holder to an absolute minimum. Now we've got to go inside to give the 3D probe a bit more wiggle room. This is a chip evacuation horror. I'm doing much worse than recutting chips. I'm stirring them almost, to the point where the occasional red-hot drop is coming out of the bottom. I've got to pause and take some drastic measures, otherwise there'll be another dead carbide tool on my conscience. I've also just tripled the chip load, and I think I should have done that much earlier. This way the chips are still nasty, but the larger they get, the easier they clean up. So that's essentially my first actually useful hard milling operation nearly complete. There's one more interesting detail in these radial adjustment screws. I'm totally going to try and mill the threads with this microscopic tool from Zorotech. The experts were not completely sold on that idea, and looking at the slender neck of the thing, neither was I, honestly. But I only needed 4 holes, and I didn't know how hard the material actually is. So what the hell, I just went for it in 2 passes. Didn't want to push my luck without lubrication this time, and what do you know, complete success. Not sure if the same tool could thread another 4 holes in steel after this, but in my opinion it did its job very well. And so did I mean obviously. I totally didn't fail around for another full day after this, trying to get the flange surface to micrometer perfection. Oh no, completely effortless 2-micron runout. Oh well, I'm still a beginner, and this was a fantastic practice piece, demanding both in hardness and accuracy. The Haimer digital 3D probe is IP64 dust and waterproof, and the battery lasts 3000 hours of continuous operation. Can't wait to put it to good use. Here's a piece of the same pre-ground tool steel that I used for other parts of the machine before. The pre-groundness is really only a convenience and time factor. One can call it square, but it's not like a ready-to-rely-on precision surface that I would install in my machine unprocessed. Oh no. Who's responsible for these terrible jokes? Okay. Stop. Haimer time. The thing is displaying -2 all the time because the spherical probe tip has a 4 mm diameter. Since we've established that it's pretty much perfectly concentric with the spindle, we can just cause a 2 mm sideways deflection to position ourselves directly above an edge. Or even better, with a somewhat modern controller like Linux CNC, we can cause any arbitrary amount of deflection and just enter the number on the display into the touch-off screen. That makes things even easier so that we can pay more attention to where we are going, and that we are not breaking off our precious probe tip there. Now I've got to make an automatic tool changer that can handle the big Haimer probe, as opposed to my normal cutting tools that are tiny on average. Then I can measure tool lengths and save them in a database, so that I don't have to Z-axis touch off for every individual tool anymore. The automatic tool changer would also make it even more unlikely for the idiot operator to press the tool change button without being in position to catch his ejected fragile carbide bit. I wonder why this thing is so dull all of a sudden. It's almost as if it's got a chipped tooth. At least it's satisfying to watch how it's cleaning up the surface to a nice and shiny finish. You can't be serious. This nice little detail comes courtesy of a Fusion 360 setting called Ignore Cusps. So this must be a cusp. Nice to meet you. I find it pretty hard to ignore, honestly. That tool really was dead, which is very inconvenient, because now I have to finish this part with a dainty 4 mm one. Oh, that'll take forever. Feel free to appreciate the performance of a nice and sharp end mill in the same material. While you still can. Halfway through, my spidey senses told me about a potentially disastrous tool shoulder/hole OD issue. We are on a lower orbit though, so surely Fusion 360 must know what it's doing. I've given it all of the correct parameters after all, including shoulder length. Well, off we go. I think this must be one of their new experimental functions, sort of a stir-welding corner chamfering combination. On a serious note, the Fusion 360 CAM processor doesn't seem to know about shaft diameter and shoulder length. That's only taken into account in simulation. I had no idea. Oh well, now I do. Could have been worse. The part looks savable, but I think I have to procure some more suitable carbide for the job. One more thing. Remember these fun experiments? I wanted to use a record player needle and preamp to measure surface roughness. Now I've got the proper tool for the job. This is a 1980 Mar perthometer, made in Hanover. They are still making these today, but a little more integrated, and with an 8 nanometer resolution. Not a huge surprise, given that the central technology is analog and the resolution theoretically unlimited. I'd be thrilled to reach any kind of sub-micron sensitivity with mine, and I'll leave the nanometers to atomic force microscopes. The green box is essentially only an adjustable linear motor that moves the sensor tip until some kind of limit switch is pressed. The sensor tip hanging on this hinge is responsible for most of the magic. Its contacts are passed straight through the green box to another control unit, which I don't have. I haven't even looked at the circuit in here thoroughly. I'm just giving the motor voltage in one polarity or the other. Noteworthy though, this is probably the lowest vibration linear actuator that they were able to pull off back in the 80s. No circulating ball bearings anywhere. Those would probably cause measurement disturbing vibrations on their own. The diamond sensor tip is attached to this seesaw piece, which can only be close to one of two coils. It's actually a super simple 3-pin inductive potentiometer. You can inject an AC waveform into pin 2, ground in pin 4, and pin 6 is the output. Pin 6's amplitude is what we are interested in. But that's not so easy to digitize, and variance over the entire measurement range is only a few millivolt. So instead I'm amplifying and measuring the difference of the sensor output signal and an attenuated version of its excitation signal. Sorry for the drastic decline in production quality. This is only an afterthought added 10 minutes before release. That way I'm getting a much more useful dynamic range, and I only have to rectify and digitize the result to get an absolute DC representation of what the sensor is going through. To map my voltage readings to actual surface roughness values, I'll need some calibration surfaces though. Thoughts? Finally, and this is pretty tough on my fragile ego, but for the benefit of everybody who is interested in building a CNC machine of their own, I'm going to list a few mistakes or misconceptions that I came to regret in my own process. First, tools steal everything. If you can import thick machined castings from AliExpress for little money, that's a great foundation, but when starting from scratch I wouldn't use steel again. It just rusts from air moisture or sweaty fingerprints, and it's very expensive to get it into the shapes that you need. Instead, I would build hollow parts out of aluminium and fill them with a high-tech polymer cement. If you do your research and get the right mixture of grain sizes, that material can have better stiffness and damping than steel. Ball screws. I wouldn't recommend using the fanciest ground ball screws. Instead, invest in linear encoders and let your position controller compensate for errors that may or may not be built into affordable ball screws. There are numerous other advantages to that. Oil, lubrication, terrible idea. I don't know what got into me. It's so hard to get the quantities right so that nothing is dripping and nothing is starving. I haven't accomplished it yet, so I have to go for dripping most of the time to be safe. Luckily, both the pump and the progressive valve are able to work with low viscosity greases as well. Linear rails? No worries, I still love them. But reputable manufacturers offer high-performance wipers or scrapers, which allow them to be operated safely in dirty environments. I wish I had gotten those, then I wouldn't have had to rush my way covers as badly. The whole thing altogether. Absolutely don't start from scratch. I recently saw a slightly used, good condition, fully enclosed CNC machine on eBay for €3,000. Even though I got my most expensive parts sponsored from companies, I still spent more than that. Plus an entire year of work. It was a particularly fun year though. I've learned a lot and I will continue to do so throughout 2020. You can do the same and make the new year one of exploring new skills or honing existing ones with online classes on Skillshare. Skillshare is an online learning community that offers a membership with meaning. There is a lot to explore there, real projects to create and a community to be a part of. Skillshare offers classes designed for real life, so you can move your creative journey forward without putting life on hold. You can learn and grow with short classes that fit even the busiest of routines, like logo design with Aaron Draplin, which might have just paved the way to a new logo for myself in only 1 hour. With an annual subscription costing less than $10 a month, Skillshare is also incredibly affordable, especially when compared to pricey in-person classes and workshops. So click the link in the video description to get 2 free months of premium membership and explore your creativity. And that's all. Thank you for watching.